I know, Mom. Yes, Mom, I know. I told the principal that distance learning was hard and that I didn't want to do it. He still made me. I know. I know. Life's not fair. I just hate it, I hate it, I hate it. I don't know where Margaret is. I definitely don't think she knew that I was crying talking to you. Oh, hey Margaret. I was just on the phone with my mom. It was about nothing at all. I'm really strong and don't get upset easily at all, so no big deal. Well, since you guys are here, we might as well talk about similarity. We started talking about congruence last time, and congruent meant that two shapes were the exact same size and the exact same shape. Similarity is similar, but it's different. So let's talk about what similarity is in terms of figures and what it means when two figures are similar. So, see that good there, Assistant Margaret?
Perfecto.
Thank you. All right. So here's one figure. We'll say it has lengths 2, 3, and 6. Cool. Now, if I wanted to draw a similar figure, you might be thinking to yourself, I'd draw one that was the same size. No, because the same size and the same shape, that's congruent. That's equal to. I just want one that's like this. So I'm going to draw one that's like it. I'm going to designate the sides and show you which sides correspond to which ones. I'm going to do a tick mark right here and a tick mark right here. These are corresponding sides. Down here we'll do a double tick mark, and over here we'll do a triple. So when you look at these figures, you can see they look a lot alike. Only difference is one's bigger than the other. That's what similar figures are. They're not necessarily bigger, but they're of a different size. Now, that size has to be special. I'll show you why. What's important about these is that these sides are not equal. This length and this length are different. But what are equal are the angles. So this angle, I'll donate it with 1 angle mark, is the same as this one. This, I'll donate it with 2 and 3. Similar figures have the same angle, but a different lengths, or they're different sizes. However, those sizes are always in proportion to the original figure's sizes. So let's look at this one. It's really easy to tell that this shape, if we start looking at these sides, we go from 2 to 4. We go from 3 to 6. We go from 6 to 12. This shape is twice as big. It's similar because it has exact same angles, and the side lengths are in proportion to the other one. In this case, the proportion, is 2x. This shape is exactly twice as big as the original shape. I could do this in any number of ways, guys. I could make the second shape a quarter the size of the first one. I could make it a millionth the size of the first one. I could make it 10,000 times bigger. I could do anything that I wanted to do as long as I kept the angles the same. They would still be the same shape, just different size versions of each other. I think probably one of the areas that you see this in the most is actually architecture and engineering. Margaret's dad was an engineer, and I'm sure that he could tell you that when he looked at a plan for an engine on a blueprint, it had some sort of scale. This has a lot to do with scale factors and sizes and ratios. Obviously, if you had a shape that couldn't be drawn on paper, but you still wanted to get those dimensions perfectly in relationship to other things, you could choose a scale factor and you could downsize a shape using the principles that are given to us by definitions of similar figures and the postulates and the corresponding axioms that go with those. So for now, and for this lesson, really the most important thing that I want you to know is that similar figures have the same angle measurement, but different side and length measurements. They're the same thing, just different size versions of each other, if that makes any sense. That's the simple way definition that I have to explain it to you. Your assignment with this is to draw a similar figure to the one that I'm about to draw. I want you to draw a similar figure that is 4 times bigger than the thing that I'm about to draw. 4 times bigger. I'm going to draw a rectangle. Going to be 3 here, 8, and 8. I want you to draw a figure that's 4 times bigger than that. Shouldn't be too bad because all these angles are 90. So you're drawing a rectangle 4 times bigger than that. And it will be similar to the one that I drew because it has all the same angle sides. Pretty cool, huh? Talk to you guys later.